Hey, welcome to another episode of 5 Minute Computer Science. My name is Mr. K, and today we're going to be looking at languages. Now, I don't mean French and German, I mean programming languages. So you might have heard of assembly language, Pascal and C++, Java and all sorts of languages. But what do they really mean? We're also going to be looking at high and low level languages. Are they really that different? And which one should you be learning? So let's put 5 minutes on the clock and let's make this happen.
All right, so let's have a quick look at the history of computer science before we start looking at high and low level languages. Bear in mind that computer science and computers wouldn't look the way they do now if it wasn't for this great man, Alan Turing. And despite the fact that you hear names like Charles Babbage and others who are accredited with computers, yes, they did a lot of work, but it wasn't until this man over here during World War II put his mind to the business of breaking the Enigma code did computer science and computers that we know today come into form. And so we need to give this guy a huge high five. All right, so let's just give ourselves a reminder of how this works. A typical instruction is made up of an opcode and operand. Okay, an opcode and an operand. Now the machine code is a low-level programming language. Okay, it's very low level, and that's because it uses only opcodes and operands to carry out its business. Okay, and machine code is it's called a low-level language because it was one of the first languages that was used to program CPUs. Now, bear this in mind: it requires an opcode and operand. So, if the opcode for adding is 111, so that bit there is the opcode, the instruction add. And the operand is the number 4, so that bit there is the operand. So we've got the opcode and the operand together create an instruction, add 4. That's about as simple as it gets. You get the opcode and the operand. So machine code is known as low-level programming languages because it requires these two parts in order to carry out an instruction. So what about another type of language that you need to be familiar with? Machine code is a first generation language. That's very true because it was the very first generation of languages used to control a CPU. However, you can imagine the opcodes must have taken a very long time and they're kind of difficult to remember. What does each opcode do and what does the operand do? And so developers produced a second generation language which is called assembly language. Now each opcode is replaced by a mnemonic which gives a clue to the operation. So whereas before here we had add 4, over here we've got something similar except that we've got a 3-letter mnemonic which kind of resembles the thing it does, and then next to that is the actual operand which could be pointing towards a register or a area of RAM or indeed within itself. So bear that in mind. So where you had addition, which might have been a opcode of say 1111, you've now just got a mnemonic like ADD or load or store or stop. So it would make it a lot easier. So if we break this down again, let's have a quick look. We've got the actual operand on this side, which is 230, and the opcode on this side. So the STA, whatever that stands for, okay, that could be store in register A, the value 230. Okay, that's a lot easier to understand than a first generation language like this one here, where you'd have to know what the code 1111 does. Whereas here you kind of get the idea by just looking at it. So why program in an assembly language? So assembly language is pretty efficient if you want to manipulate individual bits and you want to process directly the hardware that you want to control. And that's because assembly language is processor specific, so or hardware specific. So you can't use the same assembly language on lots of different platforms and hardware because the assembly language is particular to that type of hardware or that type of CPU. But it does allow you to control what you do with that hardware, and it occupies less space than machine code. So there's lots of benefits here. And good examples here for you to remember in the exam are embedded systems, real-time systems, mobile phones. All these devices can be easily coded using assembly language as they manipulate the hardware directly. What about higher level languages? So, of course, low language languages a good job, and they were around for quite a while. But then high-level languages came out, and this really transformed the way programming is done. And the reason for that is high-level languages look very different to low-level languages. You've got machine code, very hard to understand. You've got low-level first-generation languages like load, register 1 with the value in B or whatever, and you kind of get this. But high-level languages look very similar to English, very similar to an algorithm that a programmer might write up. So this makes it a lot easier to program, a lot easier to understand. And there's a lot more error checking that can go on using high-level languages. That's the main thing for you to bear in mind. They appear as though they're just English instructions in an algorithm. And the nice thing is, for a single statement like float surface, the high-level language is just using one line of code. But within a low-level language, you might have had 8, 9 different commands, and within the machine code, you might have had 20 commands.